This is Vijay from Dynatech in India. In this video, I will be showing how to bond a strain gauge on concrete. Concrete is a non-homogeneous material. Its surface is uneven and porous. Strain gauges cannot be bonded directly to such surfaces. As a start, the surface is thoroughly washed with water and scrubbed repeatedly to remove all loose particles and dust. Scrubbing with soap water helps to remove the dirt better. It is rinsed thoroughly with water and wiped dry. CSM3 degreaser is used to remove any traces of oily contaminants. The surface is then cleaned with MPrep conditioner, which attacks and dislodges dirt from the surface. Scrubbing with conditioner is repeated a few times until all the dirt is removed. Finally, the surface is scrubbed repeatedly with MPrep neutralizer to clean out all contaminants from the surface. The surface is then dried with a hot air gun. To fill out the pores and uneven surface of the concrete, M-Bond AE10 adhesive is used. This adhesive comes as a jar of adhesive, curing agent, a measuring pipette, and stirring rod. A silicone gum pad and an aluminum backing plate is also needed, and these can be of different sizes to suit the size of the gauge. A spring clamp or dead weight is used to apply pressure. A measured quantity of the curing agent is taken and poured into the jar of adhesive. A stirring rod is used to mix the adhesive and curing agent thoroughly. The mixing process should continue for about 5 minutes to ensure that the adhesive and curing agent are mixed completely. The mixed adhesive is then applied to the surface of the concrete to fill the pores and uneven surface, and the adhesive needs about 24 hours to cure fully. It is then abraded using a variety of tools and abrasives to remove all excess adhesive from the surface. A fine grit abrasive is finally used to produce a flat, uniformly smooth surface free of any voids. This is continued until the level of the adhesive layer is about the same as the concrete surface. After brushing away the loose particles and dust, the surface is cleaned with CSM3 degreaser. A 400 grade silicon carbide abrasive paper is used to finish the surface with MPrep conditioner. The liquid on the surface is wiped away with a clean gauze pad, first in one direction starting from the middle, then folding the gauze pad over and wiping in the other direction, once only. Finally, the surface is scrubbed with neutralizer using a cotton tipped applicator. And wiping away the liquid from the surface with a clean gauze pad as before. The liquid is allowed to evaporate completely and leave the surface dry. Because the concrete is non-homogeneous, it is necessary to use a strain gauge with a long active grid length to pick up the strain over a large distance and get a good average of the strain on the surface. Here we use a micromeasurements type EA-06-20 CBW-120 gauge with a grid length of 50 mm. It is laid on a glass plate cleaned with MPrep neutralizer. Due to the long length, it tends to curl when removed from its plastic carrier. So a small clean aluminum plate is placed on top of it to hold it down on the glass. The gauge is then overlaid with PCT2M tape. The exposed part of the tape is discarded and the length of the tape is taken from the dispenser sufficient to cover the gauge. Beginning at one end of the gauge, the tape is held over the gauge, touching it down at one end on the glass plate. Then gradually smoothing the tape down onto the strain gauge. Till it covers the entire gauge. The tape is folded at the end to make a handle so that it can be used to lift the gauge from the glass surface by pulling on the tape at a shallow angle. The tape is placed on the prepared surface of the concrete. Then folded back to expose the underside of the gauge. A freshly mixed M-bond AE10 adhesive is applied to the exposed side of the gauge and also onto the surface of the concrete to cover the entire gauge length. The gauge with the tape is held over the surface, and with a folded gauze sponge, the tape is pressed down onto the surface with a smooth, firm action to squeeze out all excess adhesive. A silicone gum pad is placed over the gauge. An aluminum backing plate is placed over the gum pad, and weights are then placed over the backing plate to apply pressure on the gauge. The adhesive is allowed to cure for at least 8 to 10 hours in this condition. It is preferable to allow 24 hours for the M-bond E10 to cure fully. Faster curing can be achieved by elevating the temperature of the adhesive with infrared lamps or a hot air blower. After the curing is over, the weights, backing plate and silicone gum pad are removed. The PCT2M tape is peeled back on itself at a sharp angle as shown. The gauge is inspected visually for any defects such as air bubbles, unevenness, or inclusion of dust particles under the gauge. The next step is to attach lead wires. The gauge is covered with PDT-2 tape, leaving the solder tabs exposed. The PDT-2 tape protects the sensitive grid of the gauge from drops of solder during lead wire attachment. Using 361A-20R solder, the tabs are tinned as shown. A type 326-DFV lead wire is used in this case. It is prepared by separating the red wire from the white and black wires with a dental probe. The conductors of the red wire are twisted into a tight bundle. Then the conductors from both the white and black wires are twisted together to form the second bundle. These bundles are tinned with solder as shown. The 361A-20R solder has a flux core. Additional flux is not necessary to get the tinning operation completed. The tinned conductors are trimmed to a length of about a millimeter or a millimeter and a half. A piece of PDT-2 tape is placed over the wires close to the end. A slight bend is made in the wire under the tape. And the trimmed ends of the wire are positioned over the tab of the gauge and pressed down to hold them in position. Fresh solder is applied to each tab as shown to join the lead wires to the gauge. Rosin solvent is applied with a soft brush to the PDT-2 tape to detach it from the gauge and remove it without any force. After removing the tape, the solder joints and the entire gauge are cleaned with rosin solvent to remove flux. The cleaning with rosin solvent is repeated at least twice to ensure removal of all traces of flux. Movement of the lead wires near the soldered connections can damage the tabs and the strain gauge. To prevent this, a strain relief loop is made in the wire by holding it down firmly next to the solder joint, then inserting a round object under the wires and pressing down the wire on the other side to form a simple loop. The lead wire is then anchored down to the surface of the concrete with Fe-2 aluminum foil tape, which has a strong mastic. This will prevent movement of the wire from damaging the soldered connections. A good strain gauge installation will normally result in the gauge having minimal deviation from its specified resistance. To check this, a model 1300 gauge installation tester from Micromeasurements is used. The instrument has resistance deviation scales of 5% and 1%. In this case, when the 1% deviation scale is selected, the indication is 0.05%, which is well within the specified tolerance of 0.15% for this gauge. indicating that the installation is satisfactory. The gauge and solder connections are covered with a layer of M-Coat A, which protects the gauge in a laboratory environment against dust and moisture. For more severe environments, M-Coat F or M-Coat J coatings can be used. To see if the gauge is working, the concrete block has to be loaded. Here it is arranged as a beam that is simply supported at the ends and loaded in the middle. The gauge is connected to a System 7000 data logger from Micromeasurements, which is driven by StrainSmart software.
Go straight, yes. Yes, go straight.
The block is loaded by driving a vehicle over it. The strain readings are displayed on the PC
Okay, stop.
and the values are recorded by StrainSmart software. A time graph of the recorded readings shows no drift in the balance condition of the gauge. Repeatable peak values as the vehicle moved forward and back over the block and a good return to zero when the load is removed is indicative of a good strain gauge installation.